So good afternoon to everyone. I will present today a snapshot of the current developments of the research data management for a specific use case concerning some synthesis data and specifically some epitaxy experiments. So we are collaborating with an Italian institute, the CNR, and University of Parma. So also our collaborators should also be in the meeting. So just feel free to add something and to interrupt me if you see it's the case during my presentation. And yeah, so during this presentation, I'm going to go through again the general concepts concerning the research data management in NOMAD. And in the last minutes, I will also show you the implementation and the current status of implementation of this workflow that we are developing in constant exchange also with the users. So I will briefly talk about research data management at the beginning, and as it was already mentioned by Christoph in the opening talk of this meeting and also in the previous days, we have different sources of data that can come from the instrument directly or also from the ELN, or they can also come from the post-processing steps that we may want to take. So all of these should be part of our research data management, and they should be actually connected together by a unified schema or structure that we decide for our data. So that there should be a rational design of this kind of structure. And we also show an implementation or an example of this structure and also the use of this structure through our infrastructure that is NOMAD. Yeah, so before going on, there are some basic concepts concerning the data model and what do we need to do as the first steps to start doing that. And as also Marcus mentioned before, it's important to have a schema that is just a conceptual description of the structure of our data. I'm using here the metaphor of the toolbox just for saying that the schema is just the blueprint or the project of our toolbox. And from this, we can actually create physical objects that are just the template, that are simply archive files, as we call them, that are shaped, let's say, with our schema, and that can contain specific kind of data. So this is how the workflow concludes. So after designing a schema, we can instantiate multiple templates out of one schema, and then they can host specific kind of data that we structured, and then we get our structure archive file. So yeah, now there is again it's very important to underline why the structure of the data is important. Actually, there are several reasons for which it's important. The first is, I would say, just the interoperability of this data, because whenever we share a language among different, let's say at a different scale, then we can also share what we mean. And so the data becomes more interoperable. And this is also fundamental for the machine readability. So whenever the structure is written in a standard way, then it becomes also machine readable, and this is necessary for the next step of the use of our data, that is the final sophisticated kind of analysis, such as the artificial intelligence based ones. And we also get a lot of advantages in structuring data that are just connected also with the data management within our lab and during the production of the data, and especially in the long run. So this data will become searchable because all of them are structured in a way that is easy to access, because it's really having the same structure and labels and tags. And as I said, it's also shareable, because whenever I'm using a structure that is used by many people, I can also exchange with them, and there is not, let's say, an understanding barrier for that data. And so all of these reasons are leading to a kind of a data-driven decision during our research activity. exactly what is structured data? It's just a hierarchical organization of our data. So this means that we have to define concepts and connect them. So also the ontologies we already mentioned several times today. And these kind of structures are actually making the data machine readable, because whenever the relationships are also standardized, so through several kind of operators connecting all the edges of this graph, then we can easily program many tools that are going through our structures. So in this case, we have the sample description. And in this case, you will see several sections that are going from the root to the leaves of our graph, and all of these are in principle reachable with the reasoner going through this kind of structures. In our context of a database, this structure is usually represented with some kind of markdown language. And I'm mentioning this because actually what I'm going to present later is how to design easily a schema for our experiment. So we actually choose indeed the YAML language, markdown language, that is the most, let's say, human readable among all the family of these kind of languages. And that's why we are trying to make it easy to design a schema for our data. And especially also, we are trying to find a flexible way to describe the data. So many use cases also foresee the change of the data set that we are collecting, because maybe we are exploring new techniques, or we can't actually standardize. And so we should need a way to structure the data in a flexible way. So YAML is accomplishing many of the needs that we need, that we have. And the tool that we are developing is also as was stated in the title, this ELN feature that is now living within NOMAD. And this will allow us simply to write a YAML file describing our structure, and then dropping this file into an upload in NOMAD. And this will give rise to an ELN visualization, so shaped on our needs, on the needs of the single use cases. So here there are some details describing the structure of our schema that I will not go through now, but you can find it also in our YouTube channel, and especially it's described in detail during the tutorial 8. Okay, so the next step that I should mention in this kind of process is actually the standardization of the data model that we are developing. Indeed, as I mentioned before, the standardization is the hardest part, first of all, and then it's also needed to leverage our the comprehension to our data to a different scale. So to be able to share directly our data with also outside our laboratory. That's why we usually design our development workflow in this way. So we start from the observation of single use cases and of their data set. And with the kind of inductive process, we are designing a data model. So we are going to the theoretical description of this data. And then from this, we can have a data model in our bag that we can use to readily describe new use cases that are coming. But this kind of process is also connected to the initial part, because actually every new use case will give some new insights to my data model. So extending its power, let's say. Yeah. So what is coming out of the design of a data model are common patterns along every use case that we find, and that we call base sections. So the structure in NOMAD is basically an object-oriented structure. So we develop classes containing the data from every part of the experiment. And we find that commonly we can describe with the same set of base section almost all the experiment, at least at some extent. And so here there are a few examples, such as the instrument, sample, or the steps of the process of the workflow that we usually do in the lab, or yeah, many other things. And yeah, so this is the starting point of the development of a standard data model that is also leading to a verification of the data whenever this model acquires a wider impact in the communities. The base action approach is also allowing us to just develop little building blocks of our data set that we can just use to compose our own, let's say, full description of our experiment. So this is the modularity approach that is also fostering the flexibility that is fundamental as we saw from this last year and a half in which we are doing this work. So this is just an example slide, and it's also, let's say, the data model that we have so far is actually also probably outdated, but I don't want you to go specifically into the structure. It's just for saying that it can acquire a pretty complex structure, and we can have also several kinds of operators connecting this structure. And this complex structure is meant ready to describe the workflow in our lab that is including all the parts of the research activity that we do, from the description of the materials that we can have in our bottles, in our shelf, to the workflow that is composed by actions that we perform and that we can somehow standardize. So this is our main goal, to catch the full workflow of the research activities. So what we get at the end, as I mentioned before, is some searchability and shareability of the data. Indeed, when we define a structure that is shared among different data sets, then we can start developing tools on top of this structure. For example, something we are working on right now is this visualizer of the workflows. So whenever we will use some of the base sections that we are defining and that we can find in the source code, for example, this activity that we can have in the lab, then they will be picked up automatically in some sort of visualization that is giving us, let's say, the next level of, let's say, data analysis capabilities, because we can visualize, for example, complex workflows directly with some visual tool such this. This is under development, so probably in the next months there will be some dedicated also discussion on this. And yes, for example, this is another advantage that we can have out of structured data, and this is just simply showing the solar cell app that is one of our most complete examples, in which we basically have a database that is very homogenized, and so some searchability tools could be produced to describe, to serve this data. So there are specific plots that are some scatter plots describing our data, and yeah, other kind of widgets also can be implemented. Okay, so these are a few QR codes that I leave here. And so the first one here is showing in more detail what I presented today, and is basically the YouTube playlist of the tutorial 8. The central one, so just feel free to screenshot your screen at home. The central one is the GitHub repo containing actually the examples of the tutorial and also the slides that I presented. While the third one here is another GitHub repo containing the examples, and also the one that I will show in the next few minutes. Yeah, so this was the end of my presentation, and also I want to thank the research team that actually collaborated with us, and I will spend some more minutes also to make some live demonstration. And yeah, before that, I also want to thank my team that was actually collaborating with the users, and also the development team of FAIRmat, that are basically the people that we are asking the developments of these features. Okay, so thank you, and let's try to switch to the web browser just to show you what I just described. So the workflow of this research group is basically to have an Excel file that I will just pick here. So this was an Excel file that they were already adopting before starting the collaboration with NOMAD. And simply one Excel file was containing all the data connected to one experiment. So this was already something existing before the collaboration, as I said. And what we did in the last months was just to go through this file and to refine a bit all the contents. As you see, there are a lot of sheets, and you can find also this one in the GitHub repo, just you want to take a look to that. And also what we developed together to this was a very general parser, allowing us simply writing some annotation in our schema, allowing us to parse directly the data from an Excel file into some kind of structured NOMAD archive. So the power of this parser is very wide, because you can just simply have your Excel file with a more or less complete data set, and you can write aside to that a YAML schema, and you will just need to upload these two kind of files into a NOMAD upload and then save to get your structured data file that you can then download or share, or let's say you can store or keep using it. And okay, so let's see if I can remove this from the window. Looks like not. Okay, so here you see my NOMAD suite. I hope it is okay, maybe better. And I already have some uploads here. So I logged in and I already have some uploads loaded here. So I will just try, for the purpose of demonstration, how this is working. So I'm just creating a new upload and then fishing my files. So I will just look for, yeah, actually this is, sorry, I have to go through. I should have prepared. Yes, okay, here we go. So I'm just selecting the schema file that, as I said before, is just a YAML file, and that is being processed, and the process is successful. So after this, I have my blueprint, the schema that is written in with this extension .archive.yaml, or JSON is the same. After this, I can create an entry that is instantiating a toolbox. So an empty physical object that I will then fill with my data in a structured way. So I just choose custom schema because the schema is coming from my file, is not a built-in. So once we get standardized with our schema, these things can be moved in the source code somehow, and they will become built-in schemas that you can always pick. But whenever you are developing this, it will be just your custom schema. And at this point, I can just choose the shape that my toolbox should have, and I will choose the MOFPE experiment. Yeah, so I didn't mention that this is metal organic vapor phase epitaxy, sorry. So I can now create an empty toolbox that will look like this. So as I said before, the workflow here is just of having just an Excel file that this time is easy, should be here in the home, okay? And yeah, I can just save and all the section will be filled. So this is just a kind of a profile that we are then processing and putting in our structured data. There are many cases in which we have raw files from instruments or from also atomistic simulation packages. So this just depends on your data set. Okay, so as you see, in the meanwhile, it was processed and all the structure that was decided in an iterative way with these users is filled. So we can just go through it and we will find the specific sections of this experiment. So there is, for example, this is an activity called growth run. The class is growth run, and we have the single steps here. And yes, so probably the next step, and this is the last thing that I wanted to show, is that we can already benefit of some standardization and the use of the base section in this sense. So we define a class called activity that has got a simple tag or quantity called method. So whenever we define this method, this will be made searchable in our infrastructure. So as you see here, this method is MOFPE growth run. So I can already exploit the capabilities and the advantages of having this data in NOMAD. And indeed, if I go in the explore button in our ELN, I can simply go here and look at all the methods that I have in my account or in the full NOMAD, depending on where you are looking at. And this is already giving an advantage because I can select, for example, all the AFM measurements that I may want to look at, or yeah, this depends on also which are the needs of the user. So this is already one of the advantages that we can benefit of. Or for example, there are other searchable parameters. Clearly, we are defining this kind of searchable parameters because it's hard to standardize and to find, let's say, an agreement in the community on what to put as a standard parameter that one should fill. Here we find also some composition. Yes. 1 minute more. I just wanted to show that we can also upload some Jupyter notebook, and I already have it open here, but basically it can be just contained in the upload together to the other raw file. And this is directly accessing the archive files that we just produced. So here, this also you can find in the repo if you want to take a better look to that. And this is just simply realizing an API query to our data repo. And so I can just get the data in the structured way in which I produced it, and I can start making further analysis. For example, in this case, we are just producing this growth rate versus location on the Bayfair plot. And this is also fostering the further refinement of this data set. For example, defining in a more standard way how the sample should look like, or this kind of thing. So structuring data is also allowing us to have a better look on that and a better possibility of refining it. So I think, yeah.
Okay, thank you. Thank you very much, Andrea.